Okay, today we're going to be discussing how to solve a quadratic equation using a factoring method. So all of the factoring methods that we've learned in previous lessons are going to come into play here. Before we get into actually solving some quadratic equations using factoring, it kind of requires a little bit of a review of quadratic functions again. If you recall from a previous lesson when we learned how to graph a quadratic function, we had a function in this particular form of y equals ax squared plus bx plus c. Now, it kind of requires a little bit of a review of, first again, what is a function, how is a function defined, where we cannot have any repeating input values. And so we saw in the graphing part how that looks and how it passes the vertical line test. Now, going forward here, we are going to be taking these quadratic functions and converting them to an equation that only has an x variable, and we'll be inputting something in place of the y variable, and we'll discuss that in a second. But what I want to do here is go to another page and just discuss a few things that will be helpful in this particular set of notes. So I'm going to go to a separate page and just kind of review a few things that need to be touched upon. So if we look at the basic function, ax squared plus bx plus c, we've got a quadratic function here. Keep in mind that this can also be written as f of x equals ax squared plus bx plus c. So the y and the f of x are interchangeable. We can write it in function notation as well. But what I want you to look at here is this. When we set this up in standard form, and remember, standard form has us taking the highest exponent value and going in decreasing exponent values. So here we're dealing with quadratics. Our highest exponent value is the 2. Now this is extremely important as we move into solving quadratic equations. What this tells us is this: the degree of the function will tell us how many solutions we have. So whenever we start solving quadratic equations, or if we solve any equation for that matter, the highest exponent, which is the degree of the function, will tell us how many solutions that we should be looking for. So when we start solving the quadratic equations, we will be looking for 2 values for x. Now, we're going to kind of touch upon some of the graphing that we did a little bit earlier, and we're going to kind of link this lesson with that previous lesson as we move forward here. So as you can see, any quadratic equation that we're dealing with, we will have two possible solutions, and we'll talk about in more detail whether those solutions will be real or complex, and things of that nature as we move forward. So, but in general, we're looking for 2 specific answers. Now, let's take a look at how we're going to solve many of these quadratic equations. If I were to make up an example per se, let's say I gave you a problem that said to solve, and it said x squared plus 5x plus 6 equals to 0. Now, what we're looking at here is a quadratic equation, and if you recognize in there x squared plus 5x plus 6, we have it equaling to 0. So instead of a y for a quadratic function, we now have a value. So in essence, this 0 has just taken the place of the y. Now, interestingly enough, That's like creating a T-chart, if you will. We've just put y, 0 in place of y, and we're going to solve the remaining equation for the values of x. We know that because it is a quadratic function, it is a second degree function, that there will be two values for x whenever I solve this. So I'll have one value of x when y equals 0, and then I'll have another value of x when y equals to 0. Now, as we'll learn through chapter 5, there are multiple ways for us to actually solve a quadratic equation. We're going to be learning 4 or 5 different ways to actually solve a quadratic equation. This first section of solving quadratic equations deals more specifically with solving them through factoring, which we learned in a previous lesson. So let's just look at the difference between solving an equation and then factoring equations. So I'm going to separate this problem into two different sides of the page. So if I take x squared plus 5x plus 6, the directions on something like this would simply just say to factor. Notice the difference between the left side of the page, where we have it equaling to 0, there's an actual equal sign we want to solve, whereas on the right side of the page we have no equal sign and we just simply ask to factor. And of course, if we went through our factoring process, we could see that this breaks up into x and x, the 6 breaks up into 3 and 2, and we have x plus 3 and x plus 2. Now, this is a fully factored problem, and at this point we would be done. There would be nothing else for us to do to factor this. We had, at this point, have broken that polynomial down into its two smallest parts. Well, this is a process that we're going to need to use in order to actually solve the quadratic equation that we have over here on the left. So it's going to become a skill that you have to develop after we introduce to you all the different methods of solving quadratic equations, on which type of skill, what type of method you want to use to actually solve the equation. In this case, hopefully we'll recognize that the x squared plus 5x plus 6 is factorable. It's not prime. So we can actually break this up. Now, keep in mind here, notice I've already preset my two binomials, but I automatically drop down the equals to 0. We cannot lose the equals to 0 in this particular case. So I'm going to go ahead and do the factoring on the left side, just like I did over there. So I'm going to have x plus 3 and x plus 2 equals to 0. Now, this is where a solving problem differs from just basic factoring. In the factoring problem, we would have been finished at this point, but here we are trying to find two values for x, or we're trying to find all of the values for x. So we have to continue forward, and this brings me back to the notes. If we look in the notes, we have something called the zero product property, which basically says if you have any two terms that are being multiplied together and they equal to 0, then you can break those two terms apart and set each one of them equal to 0. So that's what I'm going to do on my example here. I'm going to take the x plus 3, so this is the first term, and I'm going to set it equal to 0. And then I'm going to take the x plus 2 and also set it to 0. Now what I've created are two individual linear equations that are very easy to solve. And so if I subtract 3 from both sides, I get x is equal to negative 3. And if I subtract 2 from both sides, I get x is equal to negative 2. Now, in essence, this is what we're looking for. We wanted to solve the quadratic equation, which meant to find all the values of the variable, and the variable that we had in the equation was x. So we found the two values excuse me, for x. So at this point in time, we are actually finished with solving the quadratic equation and finding the two x values. What I would like to do, however, is bridge this back to a previous lesson when we learned how to graph. And if you recall, we learned how to graph in intercept form, which gave us the two intercepts of the quadratic equation, the two x-intercepts. In essence, that's what we found here. If you look at the y that I've created up here, we basically said that the y was equal to 0. So what this means is that any time that the y is equal to 0, x can equal to -3, which would be the point -3, 0, as well as x could equal to -2. So we also have the point -2, 0. What we've created here are the x-intercepts of this quadratic function. So when we solved this quadratic equation, we actually found the two x-intercepts of the quadratic function if we were to graph this. So we can see this, for example, when we go to our calculator, and we know that f of x means the same thing as y. So I'm just going to go ahead and graph this particular quadratic equation that we had, which is going to be y equals, or f of x equals to x squared plus 5x plus 6, and if I hit enter, we see that we have a quadratic equation, a quadratic function that creates a parabola, and if you look very closely, you can see that it's hitting the y-axis, the x-axis in a couple different places. Now it's a little difficult to see, so we're going to zoom in just a little on this and try to get a little closer look at it. And so now if I bring this down a little closer, I can see it's crossing the x-axis in two spots. The problem is I can't really get a good feel as I zoom in what those two spots are. So I'm going to use a function on my calculator that's going to help tell me what those spots are. And if you recall, the analyze graph function that we use to find the intersection, we can also use that to find the zeros of the function. Now I'm going to explain what that means here in just a second. So if I want to find the first zero, I'm going to do my lower bound, and I do upper bound, and you can see here that I have -3, 0 for one of my intercepts. And then I can do the exact same process again. I can find the other 0, and you can see that it's -2, -2, 0 as well. So those are our two x-intercepts, which we found when we solved the quadratic equation. And basically we made a big t-chart. We made y equals to 0 and found the two x values that went along with y. Now notice on our menu it asked us, when we found to analyze, I said we were going to find the 0. Well, there's some terminology here that you need to become familiar with, especially as you move forward in math. When we ask you to find the x-intercept, that x-intercept could also be called the same thing as a 0 of the function. It could also be called the root of a function. So if you see in the directions to find the 0 of the quadratic function or the function given, or if it asks you to find the roots of the function, then in essence what you're doing here is finding the place where it's crossing the x-axis and getting the x-intercept. So all of these terminologies are synonymous. They all kind of mean the same thing, and you may see it given in different methods as you go through different types of activity. So just be aware of the possibility that you may see terminology a little different. Now, that gives us a good overview of the difference between factoring by itself and solving quadratic equations using factoring. It gives us the link of our answers when we solve a quadratic equation and the graphing that we've done in the previous lessons. So this gives us a nice overview of quadratic equations. So we can now move forward in this lesson and use this information to work the various problems. Now we have two examples here, Part A and Part B. One of Part A is your more basic plain Jane problem. It says to solve the given quadratic equation, and we can recognize that x squared plus 3x minus 18 can be factored comfortably, and then we'll use the zero product property to break those into two separate equations and then come up with our solutions to that particular equation. If you look at B, however, we have a little bit of a problem. In part B, the equation is not set equal to 0, and this is an issue. In order for us to actually solve this quadratic equation and use the zero product property effectively, the two parts have to be multiplied and be set equal to 0. So what we're going to do first is we're going to move everything on the right side over and get 0 by itself on the right side before we do any of our factoring and before we are able to solve for the particular values of t in this case. So what I want you to do is use these two examples to help you solve the problems in sample problem number 1. So go ahead and take this time to pause the video and work on sample problem 1 part A and part B. Okay, so if I'm looking at sample problem 1 part A, I would look at x squared plus 15x plus 26, and I would need to find all the combinations of factors of 26 and narrow it down to the pair that can actually add up to 15. So if you need help remembering how to do factoring, you need to go back to the previous lessons on factoring and work that out. So in going through this, I know it's going to break up into two binomials, and notice I take my equals to 0. This is a very important part of this. We cannot just magically drop that. It doesn't disappear. It still has to be part of the equation going down. Factoring is just part of the process in this case. So x squared breaks up into x and x. 26 can break up into 13 and 2, and it's going to be a positive 13 and a positive 2, which is going to give me a positive 15x. Now, the factoring part of this equation is done, but I still need to solve for the individual x values. So what I'm going to have to do here is I have two terms being multiplied together equaling to 0, so I can break each of those up individually and set each one of them equal to 0 on their own. And what happens here is I subtract 13 from both sides, so I get x is equal to negative 13 as one answer. And then I subtract 2 from both sides, so x equals to negative 2 for the other answer. And I've given my two values for x in solving this quadratic equation. X equals to negative 13 and x equals to negative 2. Now, if I wanted to check this and I wanted to know if this were absolutely correct, what I could do is take each of the individual x values and plug them back into the original equation for all of the x parts, and it should come out to be 0 equals to 0, which is a true statement. So that is the way you would check your given solutions. Now, in moving over to part B, I run into a different problem again. If you notice, the right side is not equal to 0, so I need to make that side equal to 0 by going through my steps, my properties in algebra that allow me to do this. So I'm going to add 3x to both sides, which is going to give me 4x squared plus 16x plus 11 equals to negative 5. Again, I'm not all the way to 0 on the right side, so I need to add 5 to both sides as well, which is going to give me 4x squared plus 16x plus 16 equals to 0. Now, we run into a situation that is similar to what we found in our factoring notes, where 4x squared plus 16x plus 16 actually has a common factor. It has a common monomial that can be factored out of that polynomial. Now, in this particular situation, if we were just factoring, we would want to take that 4 out and keep it because it is one of the factored parts of the polynomial. However, since we are dealing with an equation, we can actually divide across the board by 4, which ends up in essence eliminating the 4 from the whole process. And this is okay because we're solving instead of just factoring. So this is going to leave me with x squared plus 4x plus 4 equals to 0. Now, by basically dividing out this common factor, it gives us a much simpler polynomial to work with in the fact that we have x squared plus 4x plus 4, and hopefully by now you're recognizing that that is a perfect square trinomial. So if I break this up into 2 parts, I have x and 2 and 2, and of course my middle sign is a plus, so it's going to be plus and plus. Now, I could write this as x plus 2 squared, or I could simply break this up into 2 parts as we've been doing and have the same exact answer for my 2 solutions. Now this creates a little bit of a question mark. We're supposed to have 2 distinct solutions because it's a quadratic equation, so the degree is 2, but our 2 solutions actually end up becoming the exact same thing. They both equal to -2 here. So if we take a look at this and see what that looks like graphically and why that looks like, I'm going to take this perfect square trinomial and I'm going to show you what that looks like on the graph. So if I come back here, I'm going to go ahead and edit out my previous graph, and I'm just going to graph x squared plus 4x plus 4. Now notice I didn't graph the original part because it was not in a function that I could graph in. I chose to eliminate to the simplest form, so this is the simple form of the equation in the function. So whenever I graph that and I hit enter, you'll notice that the graph only hits the value one time. The graph only hits the x-axis one time, and that one place is at -2. Now let me show you another function that you can use. You can go to the analyze graph and you can do a minimum or a maximum, and this is going to tell us what our vertex is in this particular case. And you can see that our vertex here, our minimum value on the parabola, is -2, 0, and so that is where it only hits the x-axis. So in these particular problems, when we're solving for the quadratic equation for x, remember we are in essence finding the x-intercepts, and in this case the graph only has one x-intercept, and it happens to be the vertex as well. So this would be the point -2, 0 would represent the vertex and represent the x-intercepts. So that's why when we have a perfect square trinomial, the graph is only going to hit the x-axis in one spot. So hopefully this video was helpful. As we move forward in Chapter 5, we will be learning other ways of solving quadratic equations. Factoring is the first way that we're going to learn, and it's generally the simpler way. However, we have learned 4 or 5 different ways to factor, so it can get a little difficult if you're not up to speed on your factoring skills. So, if you have any questions, be sure to ask in class, and we will review this as necessary.